left out one key concept, okay, is that this thing will eventually sum out equals to 0, okay. You have to set up the equation, okay, this is the equation, right? You have to set up the equation equals to 0, okay, in order for this thing to close loop. Okay, what does this mean to close loop? Because when where you start off is where you end, okay, so this is why we want it to be, equals to 0. Because if it's in terms of some values, eventually it doesn't goes back to 0. Okay, so this is why we want to create a polygon, So with this in mind, let's start off with the first part of setting up the polygon itself. So we have to first define the direction of the vectors in order to plot a vector polygon. Okay, so this is why we have to plot. We have to know what are the vectors that is in terms of that. Okay, so apparently this is the x and this is the y axis. Okay, so you may allow me to. Okay, so we have the x and the y axis, and so sorry, if this is the portion over here, as you know, from the trigo, this is a, this is some angle, and then this length over here is actually a cosine, this is theta, then theta, and then this portion will be a sine theta, if you remember. If you don't remember, you can just do yourself. Eventually you'll know that this is a cosine theta. Okay, so with this concept, so we know that this is f naught. F naught is the hypotenuse. Okay, if you remember from here, this is the hypotenuse, a cosine theta. So hypotenuse cosine theta equals to this portion over here. So this is why f naught cosine omega t is our length over here, I would say. So therefore f naught is the magnitude, while the cosine omega t is this portion over here. So this is the thing. So maybe because I want you to fully understand what I mean. So let's say this is f naught. So you have an f naught magnitude. Okay, and then you have a omega, because you're going in this. If you are going anti-clockwise, it's positive, or if you are going clockwise, it's negative. So this is the function. I mean the understanding. So this is this. And hold on. So if you remember, um, last few videos we actually do out the changing the sign to cosine, right? So I actually previously was let's say just now previously was sine omega t minus theta, right? Plus sine, right? So it should be, so for our case this should be plus sine, okay? Plus sine omega t minus theta. So to convert it, okay, you have to be minus, right? So this portion should be minus. Okay, so this portion should be minus, and therefore the rest of the angle are minus also. Okay, and therefore because when you sub in over here, sub in this into this portion over here, should be also minus, because yeah. So this is the careless mistake I previously made. So just to reinforce. Okay, so let's come back here again. So now okay, so later we'll talk about it later. So talk about this first. So this is this portion over here, and this portion is omega. The magnitude itself is omega square xm, right? So how do we know it's in this direct position? It is omega t minus theta, and theta is this big angle over here. Okay, this is omega t, and we assume that theta is some angle that crosses this. Okay, theta may be this angle. Okay, this may be minus theta, this may be minus theta. Okay, so in order to exaggerate, okay, but apparently not exaggerate, but rather than This is just a general idea. Okay, because after those who created these equations, they realized that the angle should be this thing, so that's why they actually drew this. But nonetheless, I can't prove to you, so because we don't have any angles to actually prove to you, so I just do it in this manner first, and then yeah, and then and just to let you know, it may be the angle. Okay, the angle may be this angle over here. Okay, so if you draw the magnitude, it's like this. So you have to be very careful when you draw your polygon. Okay, it may be any function, so you have to be very careful. So yeah, so if you draw this big angle, you eventually know that this magnitude will be over here, right? And then let's do with the third function, c. Okay, in this case, this is cwx. This is the coefficient. Okay, so therefore we draw it in the blue color because this is wt minus theta is this portion over here, this point over here, right? And then you minus pi over 2. Okay, so minus is going clockwise, so pi over 2 is 90 degrees, and this explains why we are over here. Okay, maybe I should use a darker blue to explain why we are over here. cwx, x, and then this is pi over 2. And then lastly, for minus kx, okay, this thing, okay, cosine omega t minus theta is this position, right? But however, we're talking about minus sign, the negative of the magnitude. Okay, as you know, the magnitude is if it's positive, it's this thing. Okay, because you are following this angle. Or however, if it's a negative magnitude, okay, it flips over. So this also explained why our kx it's this direction. Okay, so I hope you get what I mean over here. Okay, this is a pretty important concept. Okay, so after you draw this, yeah. So problem. Okay, how to determine the magnitude of the polygon? Okay, so um, how do you know this magnitude is this? How do you know this magnitude is this? How do you know how long the magnitude? And how do you know the angles? Okay, so apparently this is just a general thing to draw. Okay, upon having some values, you may actually know the magnitudes and such. Okay, in this case, we are dealing with a lot of general formula. We are doing it just with the general formula, that's all. But let's say, and typically kx should be larger than the rest of them. I think so, because uh, let's write down here. So for factor polygon, the kx should be largest, as taking the sense that the spring is springy. Okay, so if you were to force, you put the mass down. Okay, let's say you pull the mass downwards. Say you pull this mass downwards. Okay, you pull this mass downwards, and then you release. The amount of force much will be in terms of the kx and the cx, right? So damping itself will deal to the cx, and the rest will be due with the kx. So the kx itself is kind of important because it actually holds the weight of the mass, nonetheless the damping factor. So the kx and the damping factor wise should be about the same magnitude in a certain sense. Okay, and also in the way saying that this thing is equals to this portion over here. So when this minus away this, you have zero displacement across the whole system. Okay, I mean zero. What I mean is zero. It will be closed loop. Okay, it will be closed loop. Okay, so it's not about displacement, but rather than it will be closed loop. That's all. So I hope that I can give you a good concept of setting up the vectors and the magnitude and the degree. Okay, the degree and the magnitude all always depend on what values you use. Okay, so maybe in the future, if you have some equations, we have some questions, and we can do it. So with this said, we can actually finally draw our polygon. Okay, so as you know, this f naught with a certain angle, so you can predict how the angle would move. You just simply know the shape. That's all. So you draw this f0, okay, and then you know that the next one following this is actually the kx, right? Kx is going in this direction, and then follow it by we have cwx going in this direction, and then we will have a closed back loop of w square xm, right? W square xm. So in all, the differences it all depends on the you can see there's a difference between kx and w square xm. Okay, so the differences is being accounted for the loss between f0 and cwx. I hope you get what I mean. Okay, because this portion here and this portion here, they actually counteract each other, so there may be some left over. Let's say this f0 is, let's say 5, and then 5 Newton, and then this one is like maybe 3 Newton. You have a 2 Newton excess, right? So apparently this differences kx and omega square xm will have minus 2 Newton, so therefore it will counteract and becomes close to 0 Newton. And yeah, hope you get what I mean, because the purpose of us getting everything to be 0 is pretty simple. It's because we want it to be a closed loop. Okay, we don't want any displacement. I mean, we don't want any, like, if you remember, if you go in this direction, okay, you'll have a magnitude of the sum of the vectors a plus b plus c plus d equals to some position over here. Okay, if you were to take a plus b plus c plus d, okay, back to the same point, you didn't move anything, right? You are not moving at all. You are coming back to the same thing. So by the law of displacement, we are actually didn't move at all. Okay, so but this displacement that I'm talking about is different from my displacement in the spring. Just to let you know, it's the different displacement. Okay, it's just saying in terms of the vectors portion. Okay, so this is a very very important concept. Okay, we will build on it. So with this said, this is our polygon matrix. Okay, and we can also draw, okay, and what we're gonna find eventually is to actually solve for f0. Okay, what is the forces that and nonetheless the forces can be elaborated with in terms of the amount of x. So our objective itself is actually to set the equation that could find the position of x using, because you have a force, right? How does this force eventually will give us our position x at the certain amplitude, right? We are curious, okay? We want to know how this force will eventually let this amplitude itself be. Will it be this x, or will it be a larger amplitude? We want to know, because we want to prevent resonance, right? If the resonance, if let's say, okay, so maybe I should hold on a while. So let's come back here, okay? So eventually you want to solve for what is f0 actually, okay? And then with that, and then we can find the position. That's like we had a glimpse, is that this is the displacement of the amplitude, right? The amplitude, the x. Okay, so eventually you want to make the whole equation become this equation over here. Okay, so that is in terms of force and some natural frequency, so that we can, because typically there will be oscillations and there will be frequencies and such. So we want to look into that. So it is a overlapping things. And nonetheless, let me finish this portion first before we go. So the difference between kx and this thing, okay, is actually kx minus omega square xm. So this thing Okay, I'm just labeling that this is part of 2. Okay, this is 2.1, which is in terms of the, okay, anyway, yeah. So imagine, so not imagine, but rather than we will be working on the difference between, the polygons itself, the position. So that's to have you get a glimpse. So this equation here for force vibration is the same as what we eventually will derive. Okay, later in the next video I'll just talk about it, how we derive this thing. And as you can see, the difference between all this thing, okay, the difference between the everything in terms of vibration, okay, only the numerator are different. Okay, only the numerator are different. The denominator are all the same. Okay, the denominator are all the same. So yeah, so all how the numerator are different is all depends on the difference between kx and omega square x, and maybe I don't know, so in the future we will learn about it. But nonetheless, this is a very key concept that you want to take note of. Okay, because it takes note of the difference between kx and this thing. Because as you know, if you eventually this is if you know the difference between these two, you'll know that you if you let's say as I say, this one is 5 Newton, this one is 3 Newton, right? You have a 2 Newton. So if you eventually you solve for it and you realize that this is minus 2 Newton, you know that the other difference is 2 Newton. You get what I mean? So this is what we are doing now. So we just take a difference between them, and when we get this value, we know that the difference between these two vectors are the same as the difference between these two vectors. So it is pretty intuitive and smart for the person who do that. So nonetheless, I'll just stop here, and next video we'll talk about how to derive the equation for the amplitude x equals to this thing. So I'll see you in the next video.